So in this video, we're going to talk about naming cycloalkanes, right? So we spoke about alkanes in general, about naming alkanes, and we could actually do one. But the main focus of this video is actually naming cycloalkanes. Now, if you see a uh, if you see a three-carbon ring, we actually call this a cyclopropane. Right? If you see a four-carbon ring, we call this a cyclobutane. If you see a five-carbon ring, we call this a cyclopentane, and these are all the parent names. If you see a six-carbon ring, which most of you guys will see in organic chemistry, we call this a cyclohexane. And we go further, right? If you see a seven-carbon ring, you'll call it a cycloheptane, eight-carbon ring, cyclooctane, etc. Right? Now, we must also bring in the idea of cis-trans when we name our cycloalkanes. And the idea is that if you have two substituents on whatever alkane ring we have, if they're on the same side, then we call that cis. If they're on the opposite side, we call that trans. Right? So let's give some examples and let's see if we could actually name these stuff. Right? So on an exam, you're given this structure and you're asked to name it. Well, the first thing I'm going to do is find my parent. And my parent in this case is actually a cyclohexane. It's a six-membered ring. Now, the second thing I'm going to look for are my substituents. Now, in this case, you may be wondering, okay, well, which carbon do you actually label carbon number one? And it's usually in the rings, you want to label carbon number one by alphabet, right? So in this case, because bromine, and this is a methyl group, since bromine comes before, or B comes before C in the alphabet, I'm actually going to start with B as the number one carbon. Now, this is carbon 4, 5, 6. Now, you may be wondering to yourself, couldn't I have, I'm going to label this in yellow, but couldn't I have labeled this as carbon 1, 2, 3, 4, 5, 6, 7. I'm sorry, 3, 4, 5, and then 6, right? So this is just 6. The idea is you would not be correct. And the reason why is because now, instead of bromine being at position 1, it is at now position 6. Or, I'm sorry, bromine would still be number 1, but the methyl group would actually be at position 5, as opposed to the original way that we labeled it, where it is actually at position 3, right? So 5 versus 3, you want to give your substituents the lowest number possible, and so in this case, this is why we went with the green color labeling. Right? So getting that out of the way, we know on carbon 1 we have a bromo. On carbon 3 we have a methyl, so this is 3-methyl. And again, we said that we couldn't have went the opposite direction because it would have been 5-methyl instead, and that is just too high. Now, putting that together, we can actually put our stuff together. But one more thing, notice that we have spatial orientation here. So in this side, the bromine is actually coming out at you, whereas on carbon 3, the methyl group is going away. And so they're opposite each other. And so when talking about cis or trans, you would say, okay, well, this is trans. So the first thing you want to write is trans. So write trans / then we do or alphabetical order. So this is 1 bromo, since B comes before M in the alphabet, dash 3 methyl, and again we don't put any more dash, we just put or parent, which would be cyclohexane. So this is how. So this is the molecular name, or the IUPAC name for the structure. Now, if the structure was drawn in such an aspect where there were no stereochemistry, then the trans would not apply here, right? So it would just be 1 bromo 3 methyl cyclohexane, right? But because we have spatial orientations being shown here in the form of dash and wedges, we actually use our trans and or cis way of naming, right? What if you're given this one? Say you're given this one on an exam. All right, and let's say this is a CH2, CH2, CH3, and here I have a CH2, CH3, right? How would we name this compound? Well, the first thing I'm going to do is locate the parent. So the parent in this case is a 5-membered ring, so this would be cyclo, right? So this would be cyclopentane, 5-membered ring. Now, what are the substituents? Well, which one I'm going to label carbon 1? Well, again, carbon 1 would be the ethyl group. Why? Because ethyl comes before methyl. Or, I'm sorry, what am I saying? So we have, so we have 1, 2, 3 carbons. So this is a propyl group. And we have 1, 2 carbons. So this is a ethyl group. So the ethyl, since E comes before P in the alphabet, the ethyl group would be carbon number 1. This would be carbon number 2. The propyl would be carbon number 3, 4, 5. Right? So this is how we would label the carbons. Now again, you could label the ethyl group as carbon number 1 and count the opposite direction. However, in that respect, you're given propyl 4 as opposed to 3, and so this is why we counted the way we did. So the substituents would be, okay, well, we have a 1 ethyl and we have a 3 propyl. Now notice that we're showing or dashes and wedges here, and so what we're saying is that we're looking at geometric isomerism, right? In other words, we have to use our cis and trans formula. Now in this case, they're on the same side, they're both coming out of us, and so to put together the name, this would be cis dash 1 ethyl, right? Again, alphabetical order, ethyl, E comes before propyl. Now it's a 1 dash ethyl dash 3 dash propyl cyclopentane. Right? So this is how we name or cycloalkanes. Now again, if the structure was written in such fashion where if the structure was written in such fashion where there were no So if the structure was written in such fashion where there's no stereochemistry or any spatial orientation of the atoms, then the cis would not be applicable. And this is how we name or IUPAC. This is how we name cycloalkanes with respect to the IUPAC formula.